Does anybody want to do Jabber, Etherpad, scribing? And do, please do so.
Okay, so blue sheets. So when I suppose we can start, right?
Yes.
Okay, so it's 5:40, so it's about time to start. So welcome everyone. This is DHC Working Group. Welcome to Chicago. So this is Note Well. If you haven't seen this, you are doing something very wrong. But please take it seriously. Okay, so the blue sheets are circulating. There's like maybe 20 people in the room, so it will be a quick thing. We need a Jabber scribe. Any volunteers? Come on, people. Okay, I see Mark is volunteering, so thank you. It's too late. Yes, yes, it is. Thank you.
Okay. Yeah, and if there's any people taking notes, please put them in the Etherpad so that others can look at them.
Okay, so if you are first time in the room and you don't know us, the co-chairs of this working group is this is Bernie Vols and I'm Tomek Mrugowski. We used to have a working group secretary, but unfortunately Shank left for other topics and he's no longer able to contribute to DHC, so he stepped down. Okay, so a bit of an announcement. There's an article in the IETF journal about DHC, so if you are interested a bit about DHC history, it's there. Okay, so this is what we have on the agenda. So right now we are going through the administrator. Then we are going to discuss the secure DHC PV6 and the Relay agent option. After that, we have a presentation about DHCP option for NSH in SFP. We have another presentation about Young data model for DHCP v4. And there are two more presentations after that. So the first one is multi-requirement extensions for DHCP v6. And we also have a last moment addition. So Jordi will present a draft about DHCP v6 option for configuring NAT 624. So that's a draft that is in int area, but it's a DHCP option. So if we have time, it will be presented here. Okay, so any comments about agenda? No? Okay, let's go on. There is no pink box, so you can stay whenever you are.
All right. So I'm Bernie Volz, as previously introduced by Tomek. And I just want to give a quick update on 3315 biz because that is a major effort by the working group to get this done. If you recall back in the late summer, we did a working group last call where we had approximately 270 issues that were raised. Some were minor, and a lot were duplicated, but we had 270 issues that we tracked. That grew a little bit as we were going through to add a few more, so we're close to about 300 total issues. We did publish the 07 version earlier this month before the deadline, and it pretty much addresses all but about a dozen issues. And so, we're getting very close. The remaining issues aren't necessarily, complicated ones or anything like that. It was just, those just didn't get done. So we hope to finish that up pretty soon. We also have one new issue which came about because of the failover draft that we're probably going to include here, is to clarify that, while the failover document uses the DHCP message space, so it uses the same number space, we want to just clarify that relays shouldn't forward those message codes because they're not UDP anyway, they're over TCP, and so there's no reason for a relay to forward them, okay? So that's something that we'll probably just wrap into this because we've already incorporated, forget what that RC was that talked about that a relay should forward anything it doesn't know.
So,
Who are you?
this is Ted Lemon. Sounds like you're saying that relay agents should filter any packet they don't know, which means that relay agents will not be able to support any new DHCP messages that we might invent in the future.
No, see, that's quite the opposite. What we're saying is that unless, right now we specifically say a relay agent must not forward in the traditional sense just two messages, and that's the relay forward and relay reply, because those are relay specific, okay? And so the question is, do we want to add the failover space, which is, I forget how many messages there are, 10, 12 message numbers that were signed from the DHCP message space. Do we want to just say don't forward those as well?
Is there any particular value to doing that?
That's the question. I mean, we could either just ignore it and say, we don't care.
Yeah, the reason I ask is because it seems like you're placing a new requirement on relay agents that probably doesn't actually make life any better for anybody.
Yeah,
So
the servers
why
have to
that
ignore
code
it
if
anyway.
it's- Yeah,
right?
exactly. The server's
I mean,
already going to...
if it's coming over UDP,
Right.
right, and they don't support failover.
Yeah.
So, I mean, that may be the best thing, is we just are silent about it and don't mention them, and that's the way it is.
Right. Or you
Okay.
could say, may discard. That way people who want to have an implementation that's slightly more, parsimonious with packets. Anyway.
So again, our plan is to publish an 08 very soon, probably in mid-April. And as soon as that's published, and as soon as we've done the working group last call completes for the relay port one, which is the next one we have to go out, we'll start a working group last call. Even though we're not yet done with the work, we do encourage people to go look at the 07. And if you find things there that we broke or you don't agree with it, or it's change you asked for that didn't happen, to let us know so that we can address that before we publish the 08. All right, thanks. Any other questions, comments?
So, Francis Dupont, this morning we discussed about new use of DHCP prefix delegation for host in the 6-man working group. So I'd like to someone, perhaps 6-man, to just check we don't need to update one or two details, including in the way prefix delegation is implemented in the servers and client, to not have bad surprise trying to use the prefix delegation and this new context.
Yeah, I mean, that whole work is kind of interesting. And, one of the things that I haven't raised yet, but I was going to send some email to the 6-man group, is maybe that they shouldn't use the word prefix delegation, because they're not really delegating the prefix in the way that it used to be, that PD kind of delegates it, okay? And so maybe there's, some verbiage there that could be changed to make that a little bit clearer, that this is not the traditional PD that 3633 provides.
Yes, but as it's not a traditional PD, there is they open the door to have problems, including not in the spec itself, but in implementation. So it's something which we should care.
Tim Winters, UNH IOL, an author of said draft. Yeah, I think we can talk about this. I totally agree. You know, if when you put DHCP PD, people think 3633 standard, and that's obviously not what we're talking about here. I think we can do a myriad of things, whether it's try to clean it up somewhere in this document, in the biz document, to clarify that there are hosts that will be doing PD and what that means, or we can just say something in node requirements that go read those drafts. And the other option is to go read all the drafts that have said to do PD in this way.
Right.
I think either works. I think, you know, Tim and I are open to making any of those changes.
Yeah, and it's maybe, since you're a co-author of the biz document, it may be something we'll want to discuss on the biz team.
Okay, Suresh Krishnan. So, like, yeah, keep me posted. Like, I want to be involved in this conversation, whatever you're
Okay.
having. Yeah. Okay. So, if there's something to be clarified, we'll make sure that happens.
Okay, thanks, Suresh.
Eric Klein. Were there changes from the 3633 text that were like meant to sort of make PD work on hosts?
Yeah, the wording in the biz document now stays away from you know, requesting router, delegating router for the most part. There's
Requesting node,
a little
delegating
section
node.
in the beginning that we talk about it just so that, you know, we can draw the parallels to 3633, but then we've replaced it with client and server.
Yeah, that
Okay,
makes-
so
Makes sense.
theoretically, non-router devices could do prefix delegation.
Right. Yeah. And with if I don't know if Francois, you know, was also mentioning with respect to the PIOX document, but PIOX and PD are like orthogonal, like both can coexist at the same time. So that was not really.
Yeah, I think it's just making sure that, you know, they're not confused, right?
Yeah. Thank you.
Brett Templin from Boeing. So I've been doing prefix delegation to hosts for about 2 years now on handheld devices. It works great. But to make it secure, you need this stuff that you're about to talk to right now.
Okay. All right. So I guess we'll start the discussion here. So the secure DHCP v6 draft is out for working group last call. It was supposed to conclude yesterday. We have gotten some comments, but it would be appreciated to get more people to review it and provide additional comments on the document. I think there's still, while the latest draft is very good now, there's still a few holes and obviously, minor little things to clean up here and there. But I think it's looking very good. I don't know, Tomek and I haven't sat down to discuss what the working group last call status is, and we probably won't do that till early next week. So people, if you can read it and provide comments, we greatly appreciate it. I didn't update it because there weren't that many. I mean, there were some comments that we've discussed, but there's on the mailing list, but there's nothing earth-shattering. It's just a few things to clarify.
So, and just to encourage people to review this draft, technically it has 30 pages, but almost 10 of them is and boilerplate references, and there's extensive section about changes. So there's maybe 20 pages of text, and so it's really not that much. And the overview of the protocol, it's like 2.5 pages. So if you don't have time to read 20 pages, just read those 2 pages and say, okay, this makes sense to me, okay? Or maybe it doesn't.
All right. So one of the comments that Jin May posted and got some discussion is this issue regarding confirm, because when a client moves from or might have moved, there's a cable disconnected, Wi-Fi session goes down and comes back up or whatever, and it's the client is supposed to send a confirm, but if this is encrypted, the problem is that only if that server or the servers that understand that encryption are available will the client get a response. And so there's a question about how we might tweak that, and there's been some discussion. I think I think people should go look at the discussion, read the draft, and then we can maybe have some more dialogue on the mailing list about that particular issue. Okay. So as Fred had gotten up, he has been asking us to revisit this old work that expired in about 2010. and this is the agent adopt document. And what this basically did was provide the server a way to tell the relay specifically what addresses or prefixes were delegated to the client and the lifetimes, or even if the client released the prefixes or addresses, that they would get 0 lifetimes to be notified. And it did it in the relay part of the packet so that the relay doesn't have to snoop, look down into the client's packet. And the problem is with secure DHCP v6, that client packet is going to be encrypted, so there's no way the relay can look down into the client's packet to understand what's going on. Okay, we did raise this issue at the last IETF, and people said, well, let's wait for SCDHCP v6 to progress a little bit further. It has progressed a little bit further. It may not be done, but I think it's time to start this particular work again to solve the relay agent problem, because there are networks where you're going to have relays that, especially for prefix delegation, that need to be notified when a prefix is delegated or released, so that it can do whatever it needs to advertise that route into the routing system or whatever. So, it died in 2010 because we didn't really have a strong argument for it, and Cable Labs, which was the main driver at the time, had been using DHCP v4 snooping for a long time, and so they just said, hey, the IETF is taking too long on this, and we're just going to use DHCP v6 snooping because they could do it. Okay, now they won't be able to, so that's why we're bringing this up. So it works pretty simply. By the relay agent includes an ORO with a RAN option, and the server responds by adding the RAN option with any of the IE adders or IE prefixes that have been assigned or removed from the client. And the benefit is relays no longer need to peek into the client's message. Next. So there were two issues, or there was actually one issue, sorry, that came up, and that was there were some concerns about potential issues with out-of-order packet delivery. But snooping has the same issues, and so is this really anything different or new? Do we need to solve this problem? And to date, it hasn't been known to cause any problems. There is the option for a relay agent to always do a lease query if it wanted to validate something. If it got some strange patterns or something that it saw a client getting a lease, releasing it, and getting the lease again, it might think that was that out of order delivery or something, and do a lease query to ask the server, well, what is the state of this particular set of leases? Maybe it's a non-issue. I don't know what people think about it. Next slide. So is it finally time to start this work? I have a draft that's ready to go if we want to make it. And what I did is took the 04 one that was the last one that was alive, converted into XML to RFC, and then added some motivation to talk about SCDHCP v6 to the draft, and also mention the out of order thing as just something that relays need to be aware of as a potential issue. So the question is it time to start this work? If so, is this the best solution? Does anybody else have any different ways they would like to solve this problem? And if we should move ahead with it, should we just publish this next version as a working group document, or does the working group want to sort of say, well, let's restart and do an individual submission and do an adoption call and stuff like that? So any comments?
Ted Lemon, I think we should just do, what you just did is great. There's
Okay,
no reason not
we'll
to.
do an 05 as a working group document.
I was going to get preachy, but I'll just say that I agree with what Ted just said.
Okay, great. Any Any objections to doing that? Okay, we'll do it. All right, thanks. This doesn't seem to work. Oh, you took it in a second. Come on up.
Good evening to everybody. Today I'm going to present the draft on DHCP option for NSH in service chain path. This draft explains how we can use the DHCP option for providing the service function path in the service chain mechanism. Next slide, please. The background and motivation. So in NS-aware service chain path, basically different elements like service function forwarder and service function chain, service function, different elements requires the service function path. So basically manually providing this option to different elements may not be scaled, because in cloud kind of deployment cases, applications will be going up and coming down. So so that we need a mechanism to dynamically provide this information. So we are following the approach of DHCP option to provide this information dynamically to different elements of service function path.
Could I just ask you to expand all those acronyms, because I don't think that most people in this room know what they mean. I certainly don't.
Yeah. Okay. This service function for SFF is service function forwarder, and SF is service function, and there is a classifier. These are the different elements of service function path.
And what about NSH?
Sorry?
NSH is the first acronym on the page.
Is a network service header. So we are going to provide the this service function path to the different elements of this service function chain using the DHCP option. Next slide, please. So this draft we are going to propose both in DHCP v4 and v6 how we can provide this service function path information to the different elements in the service function chain. So we are actually in this. So we are considering this service function controller. Basically, this will provide the service function path information to the different elements in service function chain. Can act as a DHCP server. So using the DHCP, putting a new DHCP option, we can actually, whenever the DHCP clients, so basically the service function forwarder, service function. So when they are coming up, they can request the service function path information. So this will not add any extra overhead on the data plane side, like so because most of the network elements will be having this DHCP client running on it. So in case this information DHCP client is already up, still and later it is configured for service function path, we can still request using the DHCP inform message, and and updates we can get from the DHCP server using the DHCP force renew messages. Yeah.
Have you got a diagram within the slide deck of just how this is all meant to work? Because it might help with the understanding if we could look at that first, and you could kind of give us a bit of a primer on things.
Okay. We haven't provided the diagrams, but we have the headers how the DHCP option v4 and v6 looks, and that is in the.
You just have a diagram of the option, not of what the architecture is like, or how this all kind of comes together.
So basically this this presentation I haven't given that complete picture. I thought like probably it's draft, it's already there. Okay. You should have aware of. So okay.
And let me just add, you know, normally we expect options for a particular functionality to be done within the working group that's working on that particular technology. So this is a little bit more informational to us, and I think we have to, I think we'll discuss with Suresh, but I think this probably belongs to the SFC working group, and this is just to let us know that, this draft exists and that we may want to monitor it. It is using the standard RFC 7227 guidelines, at least for sort of the outer encoding. There's stuff inside that might not be, I haven't looked at it in detail as to, how well it conforms or whatever. But again, that's really their area of expertise as to what that information is.
Yeah, Suresh Krishnan. So I agree with you, Bernie, right? So like the thing is, like in DHC, right? Like we don't do the options for specific things in this group, so we don't take it up here, but we take it up in the group where it's done. And then we review the document to make sure it meets the guidelines, like either at the end or like it's really good that you brought it here and presented it.
Okay.
And so if there's immediately something wrong, like you'll get that feedback. But if you reach 7227, that's kind of like what we are expecting. Okay. And the work is taken up in the group where it's needed. So like for software options, we take it up in software. For SFC, you need to take it up in SFC. And I can probably send a note to the chair saying, hey, he presented it here. And if you adopt this and like send this forward, like we'll do another review and you do that when you're done.
Okay.
Okay.
Yeah.
So the SFC would be the right home for this.
Okay.
Okay.
Yeah.
Perfect. Thanks.
Yeah.
So
Thank you.
why don't I should just continue? I just wanted to set the background so people understood that this isn't something we have to bless per se.
Yeah. Yeah. As I said earlier, like this SFP information dynamically changing because in cloud deployments cases, these services will be going up and coming up, and the path information we need to be updated accordingly to the different elements of service function chain. So this can be achieved using the DHC both in V4 and V6. In V4 we can use the reforce use message, and V6 we have the reconfigured message. Next slide, please. This is the format of NSH header for DHCP V4. This is, you can see 8-bit code. Still, it's not decided. The length will be in 32-bit words of 8 bits, and we have the SSP information. Yeah.
Can you tell me what the reserved field is for?
As we haven't decided anything, but just we have reserved something. Probably in future, if required, we can use that information.
So in the future, you might have an SFP option code with the same option code number, but that has, or I'm sorry, is this part of an SFP data structure?
No. This is the option header. How it looks. Is a DHCP v4 option header, how it looks.
Yeah, so I just don't understand why you would have a reserve field there, because if you're going to have a new header with a new option with a new format with different data in it, wouldn't you just use a new code?
Okay. Actually, we are looking for the because this draft depends on the another draft, NSH draft. So, like, we are just looking with anything we need to give the further information. So just we have reserved, but yeah, your feedback is yeah, we'll definitely take care, and we will we'll check in next draft.
Thanks.
Yeah. Next slide, please. This is the how the format of NSH for DHCP v6. You can see the 16-bit option field and 16-bit length, and is followed by the variable length SFA information. Yeah. Next slide. So this current status is like, so there is one more draft on NSS header in SFC group. Still it is under progress and it's not standardized. So since our draft very much in line and it depends on other draft, we are also just closely monitoring that one. Once it's go to the RFC stage, like we can make further versions of this draft. Yeah.
I'm Chongfeng of China Telecom. I remember that in SFC working group, that's a working group document of SFC control planes. This is a working group document. It mentions that the SFC service function is set up, maintained and recovered by the control plane. So I'd like to know the relationship of this DHCP with the control planes. We need to clarify this.
Yeah, basically, this SFP SFP control plane. Yeah. So this SFP control plane basically, so still that is not standardized. The thing was, we don't want to put any control plane information in the data plane side. Like, so you need to avoid this. Still, that is also in draft state because there are two different kind of opinions on this control plane thing.
Okay,
Yes.
with my co-chair hat off, I have a question.
Yeah.
So how big is the SFP information that you are thinking that will be sent?
So basically, the SFP information, it will have a service path index. So the service path index is derived from the classifier. So once you have the service path information, you will have the service path function that could be the same node or it could be the different node which exists. So that actually tells how the packet is supposed to be processed during the service function chain.
Okay, so are we talking about like maybe, I don't know, 20 bytes, 50, 100?
Yeah, yes. So it could be around, yeah. It depends on how much, what is the service path length. Basically, how many elements are involved in packet processing during the life cycle of this packet.
Okay, so this option may or may not be appropriate if you have more data. Before, you know that the length is limited by length of the length field, right? So
Okay.
the biggest option can be 255, but
it's
very uncommon to have that kind of big options in DHCP before. So
sorry, you are saying about DHCP v4? Yes.
So Tomek, that's actually not correct because we have TED's concatenation capability, so you can concatenate multiple options into one long one.
okay, so technically that's true, but if you need to use it, then you might be experiencing other problems.
Okay. Yeah. Yeah. So what next? So we are actually looking for the more comments on this draft so that we can incorporate in the next version of the draft. And probably we are since so we actually, this is an experimental stage. So we are looking for the with some university students and to start this to have some working kind of prototype. Yeah. And yeah, viewers feedback and questions. And finally, I would like to say my sincere thanks to Ted, who has provided these feedbacks review in the draft 00. So all these things we have incorporated in the current draft. Yes.
Thank you.
So, and I will assume that this work will be done in the SFC working group and will be updated from time to time just to let us know how it's progressing.
Okay. Yeah. Yes. Thanks, Benny, and thanks to me.
Okay.
Hey.
Hello, everyone. I'm Yan Gang from Huawei. Due to Chen Xin, his visa have some problem. I help him to make this presentation. Next slide, please. Okay, it is the young model of DHCP v4. It include the server and the relay and the client three part, include the configuration and the operational data. Also, we also define some RPC. Next slide. This is its structure. There are two subtree, DHCP configuration and the DHCP state. In each part, include server, relay, and client 3 subtree. Finally, we also define some RPC to clear the statics of server, relay, or client. Next one, yeah. In order to support different devices, we define 3 if feature for the function pruning. Then different device can support a server or client or relay alone. Yeah, next one. Yeah, it is the server's configuration YANG tree. Include the basic configuration like list time, ping number, and the timeout, and DHCP options. The most important is DHCP IP pool, the pool configuration, and and some the mapping, the manually mapping MAC address and IP address and some section. Actually, at the beginning, we want to define the IP pool as a separate module, but finally, we cannot find more usage, so we just define IP pool here. Later, if somebody feel it is we need to have a separate IP pool defined, maybe we can discuss. Next one. Okay, it is the option defined. Server ID, and the domain name, and the server IP address, and so on. So we just list here. Next, please. Okay, relay configure subtree include group name, interface, gateway address, and the server address. Right now, it just includes the almost the basic configuration. We don't do some more design recently. Yeah. Okay, it's client. Next one. Yeah. It is state. It is record almost all package static information and the host allocate status, and also we define it for server, relay, and client 3 part. Next, please. Yeah. It is a packet defined. Each packet we define one parameter. Server and the client, it is separately. Next, please. Okay, we have the packet statics, but sometimes the user want to clear this information, so we define 3 RPC here for servers to clear server statics and the relay statics and the client statics. Okay, next, please. So actually here, it is not, this design is still not so good. We still have some problem. The first is it still keep alignment with DHCP v6 YANG data. We don't know later we need put together or not. The other, because now YANG have 1.0 and 1.1 version. Due to 1.1, they don't many usage. So about RPC design, right now we only use select RPC. We don't use action now. Also, here we only define the configuration and the state information. Right now we don't define the notification. Maybe later we can add this part. Also, it is just almost the basic DHCP function. Later, maybe some new function, new message, we can add it to new version. So,
sorry, Ian Farrer. I'm one of the co-authors on the DHCP v6 YANG draft. So when you showed a list of the options that you've got in your V4 model, was that just an example, or was that the complete list of the options that you've modeled at the moment? That was the slide, yeah.
Yes.
That's the complete list, is it?
Right now, not all.
So have you tried to model every option?
So about this part, can we discuss after?
I mean, the reason I asked the question here is
actually, recently I'm not expert of this domain.
Okay.
So I just have
the reason for the question is that we've had a lot of discussion on the DHC P6 model about how comprehensive do you make your modeling of the options?
Yeah.
How do you provide future extensibility? And I mean, I think we've got some kind of consensus on how to do this now. So it might make sense that we keep the two aligned there.
Okay. Then we can confirm.
Yeah, and hopefully this is Bernie Volz, hopefully we will get an update on the V6 Yang model sometime, because, and also that we were hoping to get a presentation here on where its status was, but the, I guess the primary author or whatever couldn't travel, so hopefully it'll be in Prague.
Okay, next.
Also a quick comment, Tomek Murulowski here. So I don't think you need to worry too much about new messages in DHCP4.
Okay, so next step, we want to fix almost all this open issue, just like, sorry, I don't know his name. Also, we also need to welcome more comments. Yeah, so we will keep on update and
Yeah, this still is an individual submission. The working group hasn't adopted this work because we were going to focus on the V6 one first. And so, it's just maybe if the V6 one were a little bit further along, then it would be an interesting question as to whether we should consider adopting it. But I mean, I guess it is a question for the working group. How do people feel about, do we want to revisit that consideration to begin work as a working group on the V4 document, or should we just leave it an individual submission for now? I guess no comments, we'll just leave it as an individual submission for now. Thank you.
Thank you. Okay, so the next presentation is about multi-requirement extensions. This is an individual draft that is looking adoption in DHC.
Hello, everyone. My name is Lin He from Tsinghua University, and I'm honored to have the opportunity to share our work with you all here today. And as you can see, I'm going to introduce our work, multi-requirement extensions for DHCP v6. The motivations which inspire us to dive into this work is that we find some problems in IPv6 address assignment and management. The first one is a mixed operation problem of multiple IPv6 addresses generation mechanisms. There exist many IPv6 address generation mechanisms in IETF standards, which bring about diversity and flexibility, and multiple requirements of address generation exist, including manageability, privacy, transition, traceback. The current situation is that for Slack, different operating systems have different default address generation mechanisms, and some address generation mechanisms are not fit for particular network scenarios. For example, some enterprise networks may disable the use of temporary addresses. For DHCP6, IANA option and IETA options shows the requirement of the clients. Requirements exist for DHCP6 servers to configure address generation mechanisms for different local networks. So we draw conclusions that mechanisms for configuring address generation mechanisms and requirements are needed. The second problem is that synchronization problem with a change in IPv6 addresses. This problem means that some network entities want to keep up to date the changes of on the changes of IPv6 addresses. There exists many address-related network entities, including switches, DHCP-v6 servers. In the current situation for DHCP-v6, ActiveList query solves a part of this problem by allowing other network entities to remain up to date on the DHCP-v6 releases. And however, the part of the problem caused by Slack and manual configurations remains unresolved. For example, without the synchronization of Slack addresses with network related network entities, errors may occur when billing gateway accounts traffic and charges hosts. The third one is an efficiency problem when processing large-scale concurrent IPv6 address requests. Although the size of the current subnet is not very large now, and the address generation function should be designed to accommodate up to 64 to the power of 2 concurrent address generation requirements. The current situation is that routers or switches handle and forward the NS messages in the current DAD process. However, if we had a central entity to manage all types of addresses in the network, for large-scale concurrent requests, the concurrent processing mechanism of server clustering techniques can be taken into consideration, and the unicast and unicast message can be utilized. Next, please. The fourth problem is a general model problem in introducing external services into the address assignment process. As identifiers, IP addresses can be mapped to other requirement spaces to support multiple functions such as authentication, traceback, and RFC 7037 introduces a radius service into the DHCP-v6 exchanges, and NIDTGA is a system which embeds user identity into the addresses to trace back the user identity later. NIDTGA also introduces the authentication service into the DHCP-v6 exchanges. So some interoperations between DHCP entities and the external service entities are designed to provide precise and fine-grained services. To summarize, we need to work out some general uniform protocol extensions or models to introduce external services into the address assignment process. Next, please. And we summarize 3 design goals and provide some possible solutions. The goal 1 is the first goal is that addresses in a network should be generated according to the user or network requirements. The second one is all types of address allocation information in a network should be within the central management. The possible solution is that we first define general address generation type and the uniform address storage structure. For DHCP-v6, we define the extensions for new options and exchange process. For Slack, we modify prefix information option of our message and the daily process, which is also can be used for menu configurations. The third goal is that general uniform protocol extensions and models for introducing external services into the process of address assignment should be built. The possible solution is that we define external service request and external service reply messages between DHCP-v6 relay or server and the external service client and server. Next, please. You guys all can see more details in the following draft. This is a personal draft in DHC working group. And most of the extensions can be achieved by extending DHCP-v6 under the premise of changing the current protocols as little as possible. And thank you for listening. Any comments?
You made that, yeah. Could you go back to the slide of motivations, 2 or 3? Not this one. Something talking about the, yeah, this one. Probably this is not the main issue of this proposal itself, but to clarify things, I don't think any message is forwarded by routers. It's within single link protocol. So in any sense, if you are just trying to say DAD is not very scalable, that's probably true.
Yeah.
Just to be accurate.
Yeah. Thank you.
Eric Klein. Broadly speaking, I think this is kind of a bad idea, specifically for the RAs.
Yeah.
That's a very bad idea. I mean, I think that if you are a network that's allowing Slack at all, then you really don't have any business telling the device what kind of addresses it can or cannot use. Furthermore, if you want to have an RA option, I think you will need to bring that part of the document to 6man, where I'm pretty sure there will be other people who will tell you it's also a bad idea, at least in the RAs. I don't really care too much about what you do in DHCP. As far as the ND exhaustion attack issue, I mean, that's sort of well known, but the solution around that is to solve it with layer 3 routing and not with more locking down of this L2, L3 pair state management problem. Let's see, what else? Well, there were others. If I think of them, I'll be back.
We propose this is we know this work may include several working group. The content may we present these ideas here. We just want to know how to deal with this work. Maybe some of the work can be divided to other working groups, or we just want to suggestions. Yeah.
Eric Klein again. I remembered the other thing I wanted to say, and that was after reading your document, you were talking about for Slack addresses, nodes that had formed addresses via Slack, via temporary addresses or auto-configured addresses, I should just say.
Yeah.
They could register them through DHCP, through some message.
Yeah.
And this had been proposed before by Suresh, and it was shot down by Bernie in part by saying DHCP is not a logging protocol. So you might need to have that to contend with as well.
Okay, thank you.
Yeah, Suresh Krishnan, author of the said draft, and also currently AD. But the thing is, yeah, so we had that discussion before, and yeah, there's a bunch of concerns, right? And what we were pointed to was like using something in the ops area, kind of like, use some kind of logging stuff, either like use something like Savvy or like some kind of collection protocol to do this rather than DHC to do this, right? So like my original thought process was like, if you're going to register your DNS name, you might as well do this, right? So that was like the original thought process for that. But yeah, I kind of see the point, like what Bernie said. So it's not like for that. So I think, yeah, you will have some difficulties here. But either way, like I think the split for 6man and DHC needs to happen no matter what, and then take it up on individual merits. But I think some of the parts in DHC are certainly suspect. but maybe you can have better luck with the rest of the parts. But I don't know, right? But I'm just saying it's just a 6-man needs to see some part of this.
Okay. Thank you.
All right. I think we won't take any action on this document, and because I think it's a broader issue with 6-man and potentially other working groups. Okay, thank you. And we have one additional presentation that was not on the agenda originally, so here we go.
Very shortly, because I think we are out of time already.
Yeah, we got 5 minutes.
Yes, 5 minutes. Basically, this work started, I think it was about 1.5 years ago. The problem is that, the question is that this work was introduced only for 464 XLAT, and I ran into the same problem which when deploying 464 XLAT in customers. And then I realized that the problem, you can switch to the next slide, please. I realized that the problem is exactly the same for all kind of NAT64 usage in any kind of protocol, never mind it's stateless or stateful. So basically, what we have done is developed a way to inform the clients about the possible NAT64 boxes that they may have, so they can send traffic depending on the destination of the IPv4 addresses. So they can get information about both the pairs of IPv6 and IPv4 addresses managed by each NAT64 box. That's basically the idea. We know that this could be done by some kind of policy-based routing and so on, but we believe that this is the more straightforward way to inform the clients and not needing other options. I can show you basically what we have in the draft is the flow diagram of the interaction, nothing new for the DHCP options, and then the next one, the information that we have in the prefix and so on. Why we are working in int area? Because we already checked with B6 ops where we believe that this work belongs, but of course B6 ops don't standardize protocols, and in the DHCP in general there is not work for standardizing options. So we decided that we need to progress in int area. It was presented already at this meeting in int area. And while we are waiting for more inputs, because I think I didn't get any comments in the mailing list, maybe only for one person in private, and that's it.
Eric Klein. I think maybe some other people said something in int area, but
yeah.
Personally, I do think that if you've reached this point where you think this is what you need, I mean, like, at what point do you maybe think like you designed the network wrong or something? This seems like maybe like one of those hey flags, like, hey, maybe I did something like a little too complicated, This seems complicated and kind of obscure.
Well, it's not just how we design the networks, but also we understand that this is needed in many other similar scenarios. So it's not just the case of my own customers. I sorted out the problem there already, so I have not a real problem, but I think it will be more simple to do this way.
Is there a document describing how you sorted it out so that maybe you could share that with other people who think they need this?
Basically using just a single NAT64 with load balancers and missing a lot of features that we could provide otherwise. So it's not really sorting the problem, but skipping the problem or jumping over the problem right now.
Maybe that's best, but
not really. If you have a bigger network, this was a network for customers that have between 3,000 and 5,000 customers. If you have a bigger network, that will really not scale the way we have done right now.
But this is a bigger network where you've got a whole bunch of V6 only clients talking to a whole bunch of V4 only clients. Like already, I think you've got a problem. Right?
No, because it's V6 only clients, so it's not a problem. It's going away from before. That's the nice thing.
It doesn't say, if you need all this NAT64, then you're not going away from
Well,
before.
in the client's lands, you still need to deploy before, you know. I mean, there are boxes there. You cannot tell them, hey, throw away your IPv4 cameras or whatever. They need to stay there for a while.
Simon Perrault, let's not make this discussion about the usefulness of NAT64, okay? I was not in the interior discussion, so maybe this was asked before, but we already have a NAT64 prefix discovery mechanism.
Yeah.
Why doesn't that work?
Because that mechanism don't allow you, if you go to the second slide, I think the exact text that the previous one. Support for destination-based routing. That's the key. That's the key thing. Maybe I need to put that in bold. The third bullet. That cannot be sorted out with the actual mechanism. If you read the draft, you will understand perfectly all that.
Okay.
There is a reference to a couple of drafts that have described all this, and actually to one draft that was describing the usage of, I don't remember the RFC, and they were missing exactly this scenario.
Okay, makes sense. Thanks.
Okay, thank you.
Okay, and I think we are out of time. So thanks for the presentation. Thanks for all the comments.
Yep, thank you.
Thank you, and see you in Prague.
All right.
Thank you.
And thank you to the Micho Ethernet pad scribes.
And Carl, there's a lot of our security work. This is a question about secure DHCP. I'll post it on the list. I just wanted, yeah, it might be my confusion, just clarifying some things. It seems like a lot of processing. I know authentication, client authentication is optional to the server. Is that true?
Yeah.
It seems like a lot of verification of the message happens after decryption. Is that
Right. Because we kind of have to decrypt before we can do
what
that.
wasn't obvious to me in the draft is, and I've only started reading it, I apologize, I know it's been way late in the game on this one, but it wasn't obvious if there were any portions of the frame that were just integrity protected as opposed to